Okay, so let's move on to chapter number 6, where we'll be dealing with circles. In my opinion, I think this chapter is actually the most important chapter in the Pure 1 textbook, simply because we don't look at circles in Pure 2, and also in exams, they would 100% give you a question or even 2 questions on circles. But don't worry too much because there aren't too many variations or questions they could give you, and we will look at all the different variations. Right, before even delving into circles, we need to look at some of the basics in order to create a circle equation. And these are the midpoint and the perpendicular bisector. So the midpoint first. So let's say I have a point here. I'm going to give it coordinates x1, y1, and another point here with coordinates x2, y2. That means the midpoint is going to be the midpoint here. This is easily found because all we need to do is just sum up the x divided by 2 and sum up the y and divide by 2. So the midpoint equation will be x1 plus x2 over 2, comma y1 plus y2 over 2. So if I say I have a point J, which has coordinates 0, minus 3, and K, which has coordinates 4, minus 5. If I want to find the midpoint of those 2 points, well, I just simply sum them up. So it'll be 0 plus 4 over 2, comma, minus 3 plus 5 over 2, giving me 2, minus 4. Very, very simple. The second basic thing we need to learn is the perpendicular bisector. So if I have a line here, this is going to be an example of a perpendicular line, right? Because we learned in the previous chapter, it just crosses at 90 degrees. This is another perpendicular line, another perpendicular line. These are all perpendicular lines. A perpendicular bisector is a very specific line because of the word bisector. Bisector just means in the middle. So if I have these 2 points here, then this one here is going to be the perpendicular bisector line because it crosses at 90 degrees in the middle of these 2 points. This line we need to be able to find, and the way we do that is we use the midpoint value, and we also use the fact that a line and its perpendicular line, because it's 90 degrees, the gradients are actually the negative reciprocals, right? We learned this in the previous chapter. So using that, we can find the perpendicular bisector line. Right, let's look at an example. So let's say, going back to the JK points, and let's say that's on the diameter of a circle with center P. And I want to find the perpendicular bisector of JK. Well, if it's a perpendicular bisector, it means it's going to cross P. So we need to find the coordinates of P, which we found in the previous example, which was 2, minus 4. Now we need to use the gradients. So I need to find the gradient of JK first in order to find the gradient of this perpendicular bisector line. So gradient, well, change in y over change in x, right? So minus 5 minus 3 over 4 minus 0 gives me minus 1 over 2 as the gradient for JK, meaning that the gradient for the perpendicular bisector will be minus 1 over that, so it's going to be 2. So we know it's going to be y is 2x plus c. Finding the c, we'll just simply plug in their coordinate, right? But make sure you plug in the coordinate of the midpoint, not j or k, because the perpendicular bisector passes through the midpoint, the p value. And if you do that, then c we get negative 8. So the perpendicular bisector line will be y is 2x minus 8. This first chapter is a very basic chapter, so you need to be able to find both of these midpoints and the perpendicular bisector as they are needed later on.